talking about triangles. And something that's probably pretty common knowledge for you already is the angle sum theorem. And all that the angle sum theorem says is if we take angle A and we add it to angle B and we add it to angle C, all three of those angles in any triangle add up to be 180 degrees. Well, why does it work? Well, we can use what we know here, and I have one typo on this, but we'll fix it. We can use what we know about alternate interior angles to understand why this is true. And it says we want to use the diagram above to show that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. Well, we can start here by saying that the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5, if we look at all of those, when we add those together, is 180 degrees. The thing is, by definition then, angle EAD is a straight angle, and straight angles, like we just said, equal 180 degrees. So instead of writing 180 degrees, we can plug in the 180 degrees for angle EAD to get a new equation, which is going to be angle 4 plus angle 3 plus angle 5 equals 180 degrees. Going back to some other vocab here. Since line ED is parallel to line AC, notice the arrow in here. We can also say that measure of angle 1 is congruent to measure of angle 4, or we can say measure of angle 2 is congruent to measure of angle 5. And if you're looking closely here, it's a little bit hidden. Two parallel lines cut by a transversal, then what we have are alternate interior angles are congruent. And lastly, because angle 1 is congruent to angle 4, and because angle 2 is congruent to angle 5, we can replace them into this equation, and I need to fix one thing here. Angle 4 plus angle 3, here's my typo, angle 4 plus angle 3 plus angle 5 equals 180 degrees. But I want to show here what was happening. And what happens is that instead of angle 4, we're going to write angle 1, because it says back here, because angle 1 is congruent to angle 4. So we can say angle 1, measure of angle 1. And then with our angle 2 is congruent to angle 5. Instead of angle 5, we can write measure of angle 2. And ultimately then, what we have is we have the measure of angle 1 plus the measure of angle 3 when you fix the typo, plus the measure of angle 5, and all of that equals 180 degrees, and not measure of angle 5. Fix that, it's measure of angle 2. We replaced angle 5 with angle 2, and even though it's out of order, we've got 1 plus 3 plus 2. If we look back at our first sentence, the measure of angle 1 plus measure of angle 2 plus measure of angle 3 is 180 degrees. Again, this is a roundabout way of writing a proof. And hopefully that this is mostly common knowledge to you. But now we're going to use our algebra skills to come up with some values of x. And you might want a calculator, you might want Desmos. But when we set this up here on the letter A, once again, any triangle has 180 degrees. That's our angle sum theorem. So 24 plus 88 plus x is 180. And when we combine here, we get 112 plus x is 180. And we can subtract 112 from both sides. And 10 minus 2 is 8. 7 minus 1 is 6. We get 68. 68 degrees for our angle. Over here on letter B, we've got some more variables. Not quite as straightforward, but it's still the same idea behind this. When we have a triangle, all three angles, we've got an x, we've got an x minus 31, we have an x plus 43. All three of those angles had to be 180. And then we use our algebra skills. 1, 2, 3x. Negative 31 plus 43 is 12. Equals 180. Use Desmos if you need to. Use your calculator if you need to. Subtract 12 from both sides. And we end up with 3x equals 168. And divide both sides by 3. 168 divided by 3 is 56. Thank you, Carly. So we look at example 2 here. Kind of looks like a bow tie. It says using the diagrams below, find the value of the missing angle measures. So let's start with the triangle to the left, because what we know is if we take 43 plus 74, and then we want to find this angle 1, which I'm going to call angle A. I'm going to use A for angle, equals 180. I don't want to put 1 in there, that'll be confusing. But if we add these two together, then we get 117 plus A equals 180. And we can subtract 117 from both sides. And that's going to give us this angle 1, which I called A. But 10 minus 7 is 3. 7 minus 1 is 6. So 63. So angle 1 is 63. And fill that in. And what do you know about the relationship between angle 1 and angle 2? Well, it's hidden in there, but there's an x in there. So if angle 1, which I'm going to label now over here, is angle 1, the thing is, angle 1 is vertical to angle 2. So angle 2 is also 63. And that's going to be helpful because we need to figure out, well, what is the measure of angle 3? So when we go back and fill this one in, we've got 79 plus 63 plus angle 3, again I'm going to call angle A, equals 180. And we can combine the 79 plus the 63 is 142 plus our angle equals 180. And we subtract 142 from both sides. And 10 minus 2 is 8. And 7 minus 4 is 3. So this is going to be angle 3. letter B. We're still finding the value of missing angles. And we've got an X, we've got an angle 1, we've got an angle 2, we've got an angle 3. And actually the easiest angle to find is angle 2. And one of the reasons why it's the easiest angle to find is because angle 2 and 91 are vertical angles. And what we know is that vertical angles are equal. So angle 2 is 91 degrees. And we can fill that in to our picture. Not too hard to find the measure of angle 3, because we see that 91 plus 72, we know 2 out of the 3 angles in the triangle, plus angle 3, again, I'll call it angle A, equals 180. So we get 163 plus A equals 180. And we can subtract 163 from both sides. And we end up with A equals 17. Well, we need to find 2 more values. We need to figure out what X is, and we need to figure out what 1 is. By the way, angle 17 degrees is really angle 3. But if we look a little bit closer at this picture, what we've got is we've got 2 parallel lines. And let me highlight that. 2 parallel lines. And maybe I'll highlight it. 2 parallel lines. Here and here. Cut by a transversal. There. And what we know is we know that alternate interior angles are congruent. This angle here and this angle there are congruent, and we just found out that angle 3 was 17 degrees, which means that X is also 17 degrees. And that's going to allow us to find our last value, which is, because this is 17 degrees, we now know 17 plus the 91. We don't know angle 1, and actually let's move this up here, the space. 17 plus 91, again, I'm going to call this angle A. We're looking for angle 1, equals 180. And now we can solve this. 17 plus 91 is 108. Plus A is 180. And then we can subtract 108 from both sides. We get A equals 72. And by the way, that's angle 1. Did too much work there. If I were really thinking about things, I could have said, well, 2 parallel lines cut by this transversal and alternate interior angles are equal. So we had 2 methods there, and maybe you saw that before me. So I'm missing my isosceles triangle theorem words here. Isosceles triangle theorem. And if 2 sides of a triangle are congruent, then the angles opposite those sides are also congruent. So when we take a look here, it says if segment AB is congruent to segment CB, then what happens is that angle A is also congruent to angle C. And what I like to say is if you go across from your tick mark here, so I would go across that angle and go across from that other tick mark to the other angle. Because those side lengths are congruent, our angle lengths are also congruent. Converse. The backwards statement, the converse of the isosceles triangle theorem, states that if the two angles are congruent, so say we were given the blue angles, which I'm going to put in red now, if these two are congruent, then once again we can do the same thing. We can go across to the sides, and then if two angles of a triangle are congruent, then the sides opposite these angles are congruent as well. So if angle A is congruent to angle C, then AB is congruent to CB. So we can look at an isosceles triangle from the perspective of the sides. We can look at the isosceles triangle from the perspective of the angles. Either way, those two things will be true. Congruent sides, congruent angles. So let's put some math to it. Now we've got the theory. And on letter A, we've got our two tick marks here. And because of that, this is an isosceles triangle. And then what we can say, because those two sides are congruent, the angle opposite each of those sides, those are also congruent. So when we set this up, I need to be able to see it, but it's 2x minus 27 equals x plus 53. Now we can solve. Solve it the way your Algebra 1 teacher taught you. And subtract the x. I like to move the letter to the left. And we get x minus 27 equals 53. And then we can add the 27 to both sides. And we get x equals 80. There's an example where we're given sides, and then we had to know that the angles are congruent. On part B, it's the same kind of thing here. Only this time, what we're looking at is we're given the angles, and then we need to know that the side opposite and the side opposite, because those angles are congruent, our sides opposite are also congruent. So this is 2x plus 6 equals 3x minus 6. And again, solve it the way your Algebra 1 teacher taught you. And subtract 3x from both sides. You get negative 1x plus 6 equals negative 6. And then we can subtract the 6 that's on the left side of the equals over to the right side of the equals. And we get negative 1x equals negative 12. And lastly, we can divide both sides by negative 1. So x equals 12. And just checking my directions here, it does say find the value of x, because every once in a while we want to find the value of an angle, but we don't need to do that on this particular problem. Example 5. This is not only an isosceles triangle, but if you notice there's a box on that triangle as well. And what happens here, because of the isosceles concept, not only is this angle 2x plus 3, but this angle is 2x plus 3 degrees as well. And once again, for the same reasoning. Angles opposite congruent sides are also congruent. And if we want to figure out the value of x in this problem, there's a couple ways to do it. I stick with this way. There's 180 degrees in a triangle. So it's going to be 2x plus 3 plus 2x plus 3 plus 90 is 180. When we combine like terms over here on the left side, 2x and 2x is 4x. 3 plus 3 plus 90 is 96 equals 180. And then we can subtract 96 from both sides. And we end up with 4x equals, well, 10 minus 6 is 4, and 8 minus 9 is 9, and that's 84. There we go. 17 minus 9 is 8. 84. Divide both sides by 4. And what we end up with then is x equals 21. Once again, I want to check my directions and make sure, find the value of x. So we're good there. So lastly, I've kind of been leading up to it as we've been working through these examples. But now that we understand these theorems involving triangles, we can look at two corollaries that are a direct result of the angle sum theorem and the isosceles triangle theorem. A corollary is a statement that follows with little or no proof required from that already proven statement. And I've kind of been alluding to that as we've been going through these notes. But it says a triangle is equilateral if and only it's equiangular. So remember, equilateral means 3 congruent sides. And if we have 3 congruent sides, then we also have 3 congruent angles. And then, secondly, you might already know this, but in an equilateral triangle, each of the angles has to be the same measure. Since there's 180 degrees in a triangle, 180 divided by 3 is 60 degrees. So each angle of an equilateral triangle has a measure of 60 degrees. Which allows us here to get close to finishing. And when we look at this one, on letter A, our triangle is an equilateral triangle. 1, 2, 3 marks. And once again, what we just mentioned is that if we have an equilateral triangle, how about I write it correctly? Then, no, I did write it correctly. Each angle is 60 degrees. And if we want to solve for x, we can divide both sides by 6. And we end up with x equals 10. A little bit more complicated picture on letter B. We want to find the values of both x and y. But as we take a look at this here, we do have this big triangle here is an equilateral triangle. So even though there's a right angle mark right here, that still is going to mean that this in the purple triangle is 60 degrees. And since this is 60, this little part here must be 30, because we've got the whole right angle there, and 60 plus 30 is 90. The thing is, once we know that, this over here is an isosceles triangle. So angle x must also be 30, because angles opposite congruent sides are congruent. So now all that we have left to do is to figure out how big is y. And what we do to figure out the y is we're going to take 30 plus 30 plus y equals 180. Well, 30 plus 30 is 60 when we combine like terms, plus y is 180. And subtract 60 from both sides. And we end up with y equals 120. This is x here, and then y.